everyone, I'm Lauren Pisanik. I'm an OpenSciEd teacher in New Jersey, and I'm excited to talk with you about Lesson 7, the humidity investigation lesson. My students love this particular lesson because they have a chance to plan and carry out an investigation, and then we have some great conversations about the results. So let's jump in and take a look at it. First, let's consider how we got here. We figured out a lot in Lesson 6 about the movement of air on sunny days, and we also figured out that air, which we've been representing in our models up to this point as all one type of particle, is actually a mixture of different types of substances, including water vapor. And this last piece, the fact that air contains water vapor, leads us to our Lesson 7 question. Where did all that water in the air come from, and how did it get into the air? So Lesson 7 is a 2-day lesson, and students will plan and conduct an investigation on day 1. The Lesson 7 investigation setup video is really helpful as you're prepping your bottle systems, and you'll want to budget time in advance to gather those materials and create the bottle systems. This is definitely a day before, not morning of prep, and it takes a bit of time the first time. But then you'll reuse the bottles in Lesson 8, and you'll have them ready to go for every year after. Here's the lesson snapshot for our 2 days of Lesson 7. I find it really helpful to think of this lesson in 2 main sense-making chunks that help us address the 2 parts of the question. Where did the water in the air come from, and how did it get into the air? There's several key moments that we'll look at more closely, but first let's zoom into that first sense-making chunk. So here's a closer look at day 1 and the start of day 2. Students recall what they figure out about what air is made of and what humidity is, and then they explore the humidity levels in our classroom using a humidity probe. This helps us to make predictions, plan an investigation, and then we'll carry out that investigation. And at the start of day 2, spend some time interpreting the data. All of these activities help us to gather evidence and to figure out that water can go into the air from many different types of surfaces with water in or on them. For the remainder of day 2, we work to explain how this is happening. How are those water molecules getting into the air? So we do this by developing individual models and sharing ideas before meeting in a scientist circle to come to consensus. And this process helps us figure out that when individual water molecules on the surface of a liquid gain enough energy, they leave the liquid to become a gas. And we call that process evaporation. So here's those 2 big ideas we figure out again, that water can go into the air from many different types of surfaces, and also how that happens, the process of evaporation. We leave this lesson saying, great, we now know how water is getting into the air. We have evidence to support it. But how does that help us explain what's going on in the clouds? And that will set us up for Lesson 8. But our goal today is to really understand Lesson 7. So let's take a look at some of the key moments. A first key moment comes near the start of day 1, after we quickly think back to what we have figured out about what air is made of and what humidity is. We use a humidity probe to measure the amount of water vapor in the air of our classroom. And also near a source of boiling water, an electric kettle works really well for that. And then also near a window. And then we compare those. I'll be honest, the first time I taught this, I skipped the mini activity and I just showed the kids a humidity probe and moved into the investigation. But taking the few minutes to make predictions and test different areas of our classroom really helps motivate the need for our investigation. So it's time well spent. The students see that humidity varies and that we can put more water vapor into the air. But water vapor isn't boiling outside. And we know there's water in the air. So where is that water coming from? They will have a lot of predictions after this. In part 4, we spend a few minutes planning how we'll test these ideas using specific materials. I find it really helpful to have all the materials we can use visible to the students at the start. It helps to streamline this conversation. We decide what data we should collect, how often we should collect it, and what's important. And here's where we focus the students in on recognizing that it's important to calculate the change in humidity, because that is what is going to tell us if water is going into the air. It's also important to take a few minutes and map this bottle system to the real world, because our goal is to apply our investigation results to be able to explain how water is getting into the air around us. For the remainder of day one, the students are going to conduct their investigation and record their data and then complete an exit ticket. And this is a short investigation. It won't take long. The teacher guide suggests having groups pick an environment to test, but when I do this with my students, I have each table group investigate a different environment. This way, we can be sure to collect data to represent each. The exit ticket also helps students to remember the purpose of our investigation. Our data leads to all kinds of observations and great conversations, but we want to keep the larger picture in mind, that our evidence shows that water can get into the air from many types of surfaces. In part 9, and now this is on day 2, we shift to the second part of our lesson question. Just how is this water getting into the air? So now we're zooming in to think about this at a particle level. The students will individually model what's happening, but adding what they now know about water and water vapor into their thinking. So this is a great opportunity for a formative assessment, because the students are building on what they already know. Finally, in part 11, we come together in a scientist circle to update progress trackers together. This is a key point in the lesson. We want to ensure all the students are in agreement about what we figured out. We've already summarized what we figured out about the first part of our question when we summarized and analyzed our investigation data, but it's helpful to review it. The main goal of this scientist circle is to come to consensus about how that water gets into the air. Definitely helpful to create a class representation of this that we can go back to in the future. If possible, I have a student using the feedback from their classmates to make a class representation, while the rest of the students create it in their notebook. So here's a few tips to help manage the planning and conducting investigation pieces of this lesson. Definitely helpful, as we said earlier, to watch the lesson 7 investigation setup video in advance. Don't forget to check the batteries in your humidity probes and test them before you do this with kids. The setup video shows Velcro to attach the humidity probe to the bottle, and that's ideal, but tape will also work. And when you're gathering earth materials to use what you have. If it's snowing outside and you have snow, great, but if not, crushed ice works. The 6.3 Facebook group also has a lot of great tips around this investigation. When it's time to conduct the investigation, even though the students have just planned it, it's really helpful to have the agreed upon procedures visible on your whiteboard or on a poster. You want to make sure that you keep the light source the same distance away from each bottle system, and set up your control, that empty container with no light source, to have better comparison data. Most importantly, it's really important to air the bottles out between classes. So I have students turn the bottles on their sides during cleanup, and then I quickly wipe down the inside at the start of the next class. You can also detach the humidity probe and wave it around. In this lesson, we add one word to our word wall: evaporation. And then we also create a consensus model at the end of day 2. And that's a consensus model that's helpful to save for future lessons. So taking a photo or saving that poster that you could come back to, it's a resource the kids can look back to. I hope some of these tips and tricks help you and your students as you move through this investigation. I think you'll enjoy their ideas and the conversations that the students share. In the next video, we'll move on to applying what we figured out to what's happening within the clouds. See you then.